Hello and welcome to Chapter 8, Section 3 Notes, Multiplying and Dividing Rational Expressions. So when you multiply and divide rational expressions, the first thing you have to know how to do is simplify a rational expression. So you can simplify a rational expression by, first, factoring the numerator and the denominator. Then, canceling any common factors in both the numerator and the denominator. You cannot cancel anything unless they are a factor, and they are exactly the same. Then you write the restrictions, because you cannot ignore the fact that your denominator has equaled 0 previously. So you set it equal to 0, you solve for x, and you make that a restriction on the domain. So let's simplify this rational expression right here. Well, remember, we have to factor. So you remember the x thing we did? We have a negative 12 on top and a negative 1 on the bottom. Well, factors of negative 12 that add to negative 1 are negative 4 and a positive 3. So we can simply, because a is 1, right here, we can say that we have x minus 4 and x plus 3. Because a is 1. Only because a is 1. Otherwise, you'd have to go the long way around and you can do the cross thing. And then on the bottom, you can do the same thing. Factors of negative 9 that add to 0 are positive 3 and negative 3. And so we factored. But now we can cancel, because the x plus 3 on top and the x plus 3 on the bottom are exactly the same. However, you instantly have to take that x plus 3, say that it cannot equal 0, and solve for x. So we subtract 3, and x cannot equal negative 3. That's a restriction on our domain, because we cannot have the denominator equal to 0, and if you forget about it later on, that would be a very bad thing. So we end up with x minus 4 over x minus 3. And that's the other part of our answer. Now, for multiplying. Whenever you're multiplying, if you look, the numbers 1, 2, and 3 are all exactly the same. The only difference is that in number 4, you take whatever's left over, and you multiply across the top and the bottom. So, we have 5x squared minus 5x. What can you take out of that? Well, you can take out a 5x, and you're left with x minus 1. On the bottom, we have x squared minus 4x plus 3. Factors of 3 that add to negative 4 are negative 3 and negative 1. Sorry for the background noise. Then you have x squared minus 5x plus 6. Well, you want to make that into factors. Factors of 6 that add to negative 5 are negative 3 and negative 2. So you have x minus 3, x minus 2 over 5x. And then you start canceling stuff. Well, from left to right, we're going to have 5x. So 5x cannot equal 0. Divide by 5. And x can simply not equal 0. That's part of our answer. Then we have x minus 1 on top and bottom. So x minus 1 cannot equal 0. Add 1. X cannot equal 1. And of course, if you see a pattern, that's up to you. Just make sure you don't get it wrong in the case that it's not always like this. So x cannot equal 3. And that's it. That's all that matches on top and bottom. So all we have left is x minus 2 on top. So x minus 2 is our final answer. And then we have that restriction, x cannot equal positive 3. Alright, so all of those things are required in order for you to get an answer correct. So let's do that one more time. Find the product of x minus 7 over x cubed plus 8 times x squared minus 2x plus 4. Well, x squared minus 2x plus 4 is the same as having that over 1. So we're essentially multiplying by that, right on top. But we need a factor. X minus 7 cannot be factored any further, but x cubed plus 8 is the same thing as x cubed plus 2 cubed. So our b is a 2. Alright, so if we're going to use the sum of 2 cubes, which is what we have, you would make that x plus 2 times x squared plus 2x plus 4. I'm sorry, minus 2x plus 4. And then look at that. We have exactly what's on top on the other side, right? In the second thing right there. Which means that we have x squared minus 2x plus 4 over 1, so those cancel. But we have to see what x equals. So we're going to come over here and we're going to use the quadratic formula because you can't factor that any further. Quadratic formula that says that negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now before you start complaining, know that we have 2 plus or minus the square root of 4 minus 16. Well, 4 minus 16 is negative 12. And ordinarily, we would keep going. But because we're talking about a restriction on the domain, we want to make sure that whatever x equals is a real number. Because there's no real solution, this is actually not a restriction on the domain. So we can multiply across. When you multiply across, you get x minus 7 on top, and on bottom, x plus 2 times 1. So your final answer is x minus 7 over x plus 2. No restrictions, no added restrictions, right? The x plus 2 is still going to be a restriction on the domain because if you set it equal to 0 and solve for x, you get negative 2. Like when you graph it, you keep going. Now, we're going to divide. Sorry. Now, the only thing that is added in division versus multiplication is the first step. Because you have multiplication, it's just like dividing fractions. You keep the first thing, you switch the division to multiplication, and you flip the second one because you're actually multiplying by the reciprocal. So we need to keep, switch, and flip. Everything else is exactly the same. Okay? So first we have 11x over 3x minus 9 times, because we switched the division to multiplication, that's the switch, and then we flip the second fraction. And then we just factor like we did before. So we end up with 11x. Can we take anything out of 3x minus 9? Yes. 3. So we're left with x minus 3. You factor the top. So factors of 15 that add to negative 8 are negative 5 and negative 3. And then on the bottom, we take out an x, and we're left with x minus 5. So now that we've factored, we start to cancel. Now, we go left to right, I guess. Doesn't matter where you start. So we know that x cancels. So x cannot equal 0. And that was pretty simple. X minus 5 cancels. So x minus 5 cannot equal 0. Which means that you add 5. My pen does not want to work. And x cannot equal 5. And then finally, x minus 3 cancels. So you have x minus 3 cannot equal 0. Add 3 to both sides, and x cannot equal 3. So now you multiply across to see what's left. So we end up with 11 over 3. Now remember, you always want to simplify as much as possible in math, but so if you had a fraction that could simplify further, you would. As it is, 11 over 3 is as simple as it gets, so we're done with that one. Last example. Find the quotients of this. So we're going to factor, okay? But before we factor, we have to do the keep, switch, flip, because that's the addition and division. So we have keep, switch, flip. So we keep 6x squared plus 4x minus 2 over 5x squared. Now, this is the same as 2x squared plus 2x over 1, So we're going to have 1 over 2x squared plus 2x. And then we start factoring. Now 6x squared plus 4x minus 2 has a GCF in it. You can take out a 2 and end up with 3x squared plus 2x minus 1. Then we do this, because a is not 1, right? We have to go the long way. We get negative 3 on top, 2 on the bottom. Factors of negative 3 that add up to 2 are 3 and negative 1. You include your x and then you write your way around. So we have 3x squared plus 3x minus x minus 1. We group the first 2 and the last 2. We can take a 3x out of the first 2 and end up with x plus 1. We can take a negative 1 out of the second 2 and end up with x plus 1. So our factors are 3x minus 1 and x plus 1. It's factors like 3x minus 1 that are the reason I go through and always set our cancels equal to 0 and solve for x. Okay, because you never know when you might end up with something like that. So we have 3x minus 1, x plus 1, and then a 5x squared on bottom, times 1 over, and in the denominator here, we could take out a 2x and end up with x plus 1. Well, that's nice, because that means we have an x plus 1 in the top and in the bottom. So x plus 1 cannot equal 0. Subtract 1 from both sides, and x cannot equal negative 1. Part of our answer. Then, the only thing I can see that we can possibly cancel is this 2 right here. So just to emphasize. Okay, because they're numbers, right? And we might as well cancel numbers if we can. So we multiply across the top. 3x minus 1 times 1 is very simply 3x minus 1. And we can put that over 5x squared times x. And x squared times x is x cubed. So we have 5x cubed, and that's our answer. Have a great day.